Hello dear teacher, in this section, in section 3, in chapter 3, we are going to talk about the derivative of trigonometric functions, which mean sine and cosine. Something here is not important, please do not follow the how to solve, or just find the know about the sine, derivative of sine is equal to cosine. Okay, so here's the example, you know in the previous one. 3.2 how to find the derivative of the polynomial. So you have a 2x and the derivative of sine is equal to cosine. That's all. Okay, try to solve these all together, because this you need the rule of the quotients square. Okay, denominator derivative of numerator minus numerator derivative of denominator is equal to 1. That's all, and 1 multiply by 1 is nothing to be changed. In the second example, we have the derivative of cosine is equal to minus sine. Here's the example: 5 cosine is equal to 5 minus sine. Also, here's the another good example. We have a two function sine cosine, so we say first multiply derivative of the second plus second multiply of the derivative of the first. They are very easy, that's why I'm not going to write it really for you. How about this example? If we say we have a quotient, how we find? We say denominator square. Here's the square, denominator square. Okay, denominator derivative of numerator is equal to minus sine. Here's minus sine, minus of the rule. Okay, numerator derivative of denominator is equal to minus 1 is equal to 0, minus of derivative of sine is equal to cosine. Now you can multiply cosine by cosine, you will get cosine square, and this one we will get what? Minus sine square. It remains what? And this part all equal to 0. Okay, this part is equal to 0, so it remains what? Cosine square, sine square is equal to 1, and then later you get to this one. Let me do it for you, this one. So 1 minus, you multiply is equal to minus, I'm going to multiply this one, I will get minus sine of x plus sine square of x, okay, minus cosine square of x, and minus by minus, sorry, we'll get plus. So this part equal to 1, and it remains 1 minus sine of cosine. And you know these are the numerator and denominator are the same, so that's why we cancel this one with the exponent, and later you get what? You get just 1 over 1 minus sine of x. Okay, dear. So for the next rule, you have this. You can benefit of this rule. The derivative of tan is equal to secant square, cotan is equal to minus cosecant. These are very important. The fourth function remains in the trigonometric function. So you see if there's a table. No, I'm going to write the table for you here to make a table for you. For example, if y is equal to sine of x, the derivative will be cosine of x. Then rule number 1, like that. Find a good place. Like this. Y is equal to sine of x, the derivative will be cosine of x. Okay, dear students, for the second, y is equal to cosine of x, the derivative will be minus sine of x. Be careful. Okay, how about the third one? If y is equal to tan of x, the derivative will be secant square of x. Number 4, y is equal to cotan of x, the derivative will be minus cosecant of x, tan square. And number 5, y is equal to secant of x, the derivative will be secant of x, tan of x. And number 6, last one, cosecant of x, the derivative will be minus cosecant of x, cotan of x. Careful, these are very important, especially for the integral. We will use them many times, so please try to control them, to understand and know and use them again and again to get this information as a knowledge, not just memorizing them. That's the forget about this, because this is the driving the tan. I don't need really drive to the tan, just we know it's equal to secant square. And now if y is equal to secant, find the second derivative. It's a good example for you. If y is equal to secant of x, find second derivative. So first of all, we are going to find the example 6 in page number 3 in section 3.3. So the first example, first derivative will be derivative of secant of x. We say that is equal to secant of x tan of x, if you remember in the previous lecture and the previous page. For the second, now we have a two function derivative of two function. We say first derivative of the second plus the second derivative of this first one, and you can summarize them or collect them as a this function. That's all that you need to do it by yourself. Please try to find the this example again and again, and forget about the example 7. Is not related to the subject. Now in the next page we have what? We have a chain. The chain means that again and again, like this. Change means that something like that, one by one, zinjira, one by one. So what do you mean by the change? You can see this example is two things together. We have a function and we have an exponent. So when you say we are going to find the derivative, you say 2 of 3x squared plus 1. This is the inside the derivative, and then inside, so we have inside and outside. Inside the parentheses, so we have what we have. Also we should multiply by 6x. Okay, that's all that we need. We say with the change we have a two functions, they are dependent to each other. That's why we are when we find the derivative, we should take care about the inside the parentheses. That's all that I want to give you the results. Here's the 6, and you multiplied. Later you can multiply, you can say 12, and what other things that you want to say about it. Here's the also going to talk about the derivative of the what do you say, the chain. Now I'm going to show you this theorem by the example that we have here. Sorry, what's happened here? Oh, the page is not clear. Okay, I'm going to print this page for you. Okay, page number 6 is not clear. I'm going to print it for you again. Here we go. We have a derivative of what? Of for example, where's the example? Here's, we have y is equal to xt, and t is another function. So find what? Find derivative. We have what? X is equal to cosine t squared plus 1, and you can find the derivative directly. You can say dx by dt, okay, because you have a dt. Derivative of cosine is equal to minus sine of t, you know. And don't forget about derivative of what? Inside the chain. Inside here is equal to t. That's all we need to know about the derivative. For the outside and inside, here's the rule. He say please follow the rule. We have the derivative, find the inside then outside. Do not forget about the number that we have here. So for this example, sine will be changed to the cosine. Okay, also you multiply by 2x plus 1. Why? Because you have here. How about this example? Tan will be the secant square. Okay, and the derivative of here is equal to 0 minus sine 2t is equal to what? To cosine 2t. But also you have 2t, we multiply by 2t. Let me do it for you. Example 3. Here's then tan y is equal to, or g of t, or anything, tan of 5 minus sine 2t, or 2x. So it will be 2x. So first of all, we have a derivative of tan is equal to secant square of this. Okay, y is equal to tan 5 minus sine 2x. Derivative of tan, we say that is equal to secant square of itself without changing any things. Now, this is the derivative. How about the derivative of inside? The inside also will be what? Will be 0 minus derivative of sine will be cosine 2x. Again, you have what? 2x. Don't forget it's equal to 2. So here's the multiplication, and better to see that this is the angle of the secant square, so the rest one will come to the front like that, and secant square of 5 minus sine 2x. Okay, dear, that's all that we are going to talk about. They are very important. Please try to, I know it's easy, I know you know everyone know about this information, but if you are not trying, or you not use the pencil and paper or pen and paper, you never get the information correctly, or you will not be sure how to solve these examples. Here's another example. I think it's easy. A and B and C. I'm going to solve the first here. You know, this one will come down, and it remains 6. Now it's time to take the derivative of the inside, was equal to 50x squared minus 4x to power 3. That's all. Okay. How about the derivative of here? You know, you can use it by two methods, using division or quotients, or directly say y is equal to 3x minus 2 to minus 1. So y prime is equal to minus 1, 3x minus 2 minus 2, which is equal to, and do not forget about multiplying by 3, because you have a 3 here inside the angle. Okay, so we'll change to minus 1, minus 3, sorry, 3x minus 2, all of them to power 2. That's the derivative of this example. You can see here the result. Do not forget about the 3. It's inside the angle. Try to, for the fifth one, it's easy. And here's a note for you. If y is equal to sine of 5 cosine or any angle without minus, because minus means that arc sine or inverse of sine. So sine with any exponent, or when I say sine, I mean cosine, cotan, secant, cosecant, cotan, all the 6 trigonometric functions with the power n, which n not equal to minus 1. You can manipulate with it. What do you mean by manipulating with it? You can write down like that. Okay, dear? Okay, so you can play with it. So now I'm going to derivative. I say is equal to 5 sine 4, and derivative inside is what? Is cosine x. That's all. So is equal to what? Is equal to 5 cosine x sine. I can put it down like that. Okay, dear? Very, very important. Careful how to use and how to find. Here's the derivative on page number 7. The derivative of the absolute value. As I told you, during the absolute value there is no derivative because you have a corner. But if you want to show how is not possible to find, how it's not easy to find, you can use the derivative by the definition, or you can use another method for showing that if y is equal to absolute value of x, derivative will not be exist. How? Because we know derivative is equal to what? This one. Y is equal to x and minus x when x greater than or equal to 0, when x is less than 0. So when you see derivative of x, this part will be 1 and this part will be what? Will be minus 1 at the same time. And you know that when you find the derivative, you should have what? One value. So you got two value. That's why we say derivative is not exist at 0 especially. Okay, dear? That's all about the function. And you can show this, you know, we say the derivative is equal to the absolute value. There's the first definition of the absolute value, and the other definition, the second one, is like that. So you can find the derivative is y prime is equal to what? As you mentioned in your lecture book, you know, this is equal to what? You can't say is equal to x over 1 over 2, because if you do like that, you will just get x and you will lose the value of minus x. That's why we say what? We say is equal to something like that. Well, how? You know, we say derivative of square root will be what? One over 2 will come down, and we will say minus 1, and we will multiply by 2x inside here, was equal to 1 over 2 x to power minus 1 over 2 and 2x, 2 and will go, and it remains x over x square. Okay, minus 1 over 2 is going to down, and you know this is equal to x over x, which may be equal to x over x, or maybe equal to x over minus x. In that case I will get 1, in that case I will get minus 1. Don't forget about the second method. I think the first method is more easier to find this one. Okay, use this one. Absolute value is equal to x or minus x, where x greater than or equal to x less than 0. The derivative will be what? The derivative will be 1 and minus 1 when x greater than 0, x less than 0. So in that case, because I got two values, so the derivative does not exist. That's all about the absolute value. Find the absolute value derivative. Okay, how about this? I think it's easy, just minus going to down, and you get minus 2 is equal to 2, and that's all. I think it's easy, nothing to be mentioned. Now we have an important things here. It's what? Implicit function. Okay, implicit, inside the function. Okay, how we find the inside the function? I'm going to tell you something that's very important to recognize the implicit function. If y in your function, for example, x squared plus 5, if your y in the function is the power is 2 or more, so here's 2 power 3, here's 2 power 2, here's 2 power 2, or you have the multiplication between x and y. Okay, you have a multiplication between x, y. In those cases, you have an implicit function. So how you can see, or you can find, here's the square. The next example, you can see you have square. In the third example, you can see you have what? X and y multiplication. Okay, dear? So in those cases, you have a what? You have an implicit function. Implicit function. How to find the implicit function? It's easy. X, like you are dealing with the x as a x, also y as a x. But after each derivative, you should put the y prime here. What do you mean by that? I'm going to tell you by the example number 1. Okay. Example 1 in page 8, 3.3. Y squared is equal to x. Now you are going to find the derivative of this function. You say what? You know the derivative of x is equal to 1. How about the derivative of 2y? Deal it with as x. If it's x squared is equal to what? Is equal to 2x, right? So I'm going to write to 2y. But do not forget about putting what? Putting y drive. by derivative. That's all. Okay, dear? That's all that you need to know about the derivative. Okay. So, the next page, okay, we have what? You can write 1 over 2y. And y is equal to what? You can write 2 square root of x, or just leave it as a y. Okay, that's all, because x is equal to square root of x. Okay, dear. Now how about I'm leaving the second example for you. It's not difficult, the same 2x. Okay, forget about the solution. Where's the solution? Here's the solution, y1 y2. You don't need really this detail, so just solve it like that. 2x x squared plus y squared is equal to 25. You can directly say is equal to 2x plus 2y y prime is equal to 0. Y prime, and find the y prime, put the rest of to the other side. So I'm going to get what? 2y prime is equal to minus 2x. Okay, and y prime is equal to minus x over y, because you have a 2 and cancel. That's all that we have. And find the value of y is equal to what? Is equal to is equal to 25 minus x squared. That's all. If he's going to give you a point, put the point here. 3 and 4, put the point here, and you can find the result. The next page 10, you can see it's easy. I'm going to solve this one for you. Say what? Y is equal to, y squared plus x squared is equal to x squared plus sine of xy. Please, if you have a sine or cosine, more than one things, put in the bracket, put in the parenthesis. اگر گوشaka یک شو زیاتر بی کره کانو بلیو تگنچه. So in that case we say 2y y prime 2x. How about this? It's very important. Derivative of sine is equal to cosine, we know. This is easy. But how about derivative of the inside? So we say is equal to derivative of inside. First multiply the second, okay, plus the second multiply by the first, because we have a multiplication of two function. Now we are rearrange it. This one will come to the first part, and we multiply by the first. So x y prime cosine xy plus y multiply cosine xy again. Okay, dear. Now let the y prime to be the other side. So you have 2y y prime minus x y prime cosine xy was equal to 2x plus y cosine xy. Okay. Now students, we are taking the y prime as a common, and it remains 2y minus, be careful and pay attention, fully attention. You can see 2y minus x cosine xy, okay, is equal to the other right side 2y cosine xy, and we need the y prime, will be equal to 2x plus y cosine xy all over 2y minus x cosine xy. That's all that you need to know about the solution. Here's the solution. You can see, you can check one by one, and you will see it's easy for you. So I'm going to leave this one because a higher derivative of implicit function, the same, you can deal with it as a simple example that we gave you before. So, and also the last page also is about finding. We have a implicit function again, but we have a point. Please find the point, but you need what here, the tangent, tangent and normal. So how we find this one? I'm going to find this one together, or solving this one for you. Students, here we have a important example. It's talking about finding example 5 note page 3.3, page 11. You see, find, if you have this point and you have this curve, then find tangent and normal curve there. So for the tangent line, you need what? You have this rule that say that the tangent is equal to derivative. Okay, so we are right, y is equal to what? M, or y minus y naught is equal to m x minus x naught. In that case, we are going to find the tangent line. But how about m? We have no m. So m is equal to what? As I told you, we mentioned in section 1, that m is equal to slope, and the means that the slope, and the slope is equal to the first derivative. That's why I'm going to find the first derivative here. So in the function that I have x cube y cube minus no xy is equal to 0, I'm going to find 3x squared plus 3y squared y prime minus 9 first second derivative plus second first derivative equal to 0. So do not forget about finding what? Finding the common. So y prime will be what? After that, I'm going to write directly. Please try at home the step, show the steps. It's easy, just right, left, and dividing. Here's the y prime, and you know this means that m. If I put what? The point 2 and 4, I'm going to get m. So m is equal to what? If I put m, I say m is equal to 3 multiplied by 4, here's x and y, minus 2 square, and again 4 square, minus 3 multiplied by 2, and the result will be what? Will be 4 over 5. So here's the slope. Now as I have also, we have a point and slope. As I told you, we have a point minus y naught m x minus x naught. So y is y, x and x shouldn't have any point. So here's a 4, y naught is 4, is equal to m, okay, x minus x naught, and here's the tangent line. Okay, the tangent line will be x minus or plus 12 over 5 after bringing this one and find the first denominator. So this is the tangent line. For the normal line, you know we have a tangent line and normal line. The relation between them is, if I have a m, this one will be 1 over m, or the normal will be 1 over m, the slope of the normal. So that's why in the normal line also I have y minus y naught, but 1 over m. Okay, راستهێڵی لێکەوت و ڕاستهێڵی جیاوازەکان ئەوە بوو ئەگەر لێکدانە کردنا سلۆپەکانی کردە یەک بۆنەوە یەک ڕەتی یەک لەسەر ئێمە کاتێکە بێ وابێ کاتەمە for tangent line and for normal line. That's why. So for normal line I have x minus x naught again, and just change what? 4 over 5, change it to 5 over 4 and multiply x by 2 and y minus 4. That's all what we have. And finally we finish section 3. So please do not forget about how to find the implicit. If you have an implicit, you have, for example, y square. When you find the derivative, you have a 2y, but do not forget putting the y prime. That's all we need in this section. Thank you for watching, and please study well. This is for this week. Have a nice time.